Everyone. In this video, I'll show a few tools using Roboflow, using Google Colab, and using Gemini as a large language model. So uh, first of all, I'll be starting here with these three models. These models have been trained on Roboflow, annotation completed on Roboflow, dataset management over here and splitting, and then we have three versions of three different models, YOLO 11, YOLO 12, YOLO 8. And I was just comparing the difference between these three architectures over the same dataset. This dataset focuses simply on segmenting or finding different tooth types and giving one classification out of 8 for each tooth available in a radiograph. So if we go back to the models here, you can of course test these models from over here, but more interestingly is you can program these models into your code, to your own software. So you go down here to deployments, and you click here on hosted image inference. You can also do video image inference, hosted video inference. So you press view code over here, and immediately you find this piece of code you can add to your own software or code. This will help you connect with the trained model on Roboflow. And as you can see here, I'm using version 3. You can modify that and call any version you'd like. So we can just simply copy this one. It's Python code. It can work greatly with Colab. So what I'm going to do next is show you these three separate Python codes. You have to drop them onto your Google accounts, Google Drive, and then connect them with Google's Colab Jupyter Notebook-like software. So when you click open with and you don't see Google Colab, just connect more apps and try to find Google Colab. So let's immediately start with that. This depends on the internet connection you have, so please try your best to find readily available high-speed internet. First of all, this is the code we have over here. I'll explain it shortly, but make sure first that this Jupyter Notebook is connected, and particularly connected to a GPU. Okay, so you can connect immediately over here. The Jupyter Notebook is usually divided into a descriptive part, such as here, and a code, like a region part. And you can go back and forth between descriptive and code parts. This describes that I'm going to use Roboflow to achieve inference here on a Roboflow model to perform predictions here on further images. I'm already connected here, as you can see, and I can start working with it. So first of all, you need to install your software. So you can just simply go with the same sequence of the code you can see here. So first install a few different third-party software or modules. It's going to install everything. Once it's done, you always see this tick over here, and then you can go on to the next part of the code. Next part simply imports these installed software, and then you start working with your Roboflow model and predict on test images you bring along with you. So I need to upload this test1 image. It needs to be in the sample data folder. Right now it's not there. So let's upload it. So it should be over here, this one, and just drag and drop it over here. It's going to give you this warning message. That's okay, it's just telling you files will be deleted afterwards. So make sure to save your output once you're done. And then at the end here, it will run prediction using the model number 2. It will try to find where the boxes are and implement them on the raw images. So you can see where the box locations are after prediction. They're all going to be in green color. This is how to define green. And at the very end, once the rectangles are ready, you're going to plot the figure and show it. So let's run this part. Great things about Python, it's easily readable. So I'm not explaining Python right now, but you can easily read into every syntax and every action that's going on. And as you can see here, the image is going to be completed with predictions overlaid onto it. So this is the first Python code, just to simply call whatever model you've completed and use Google Colab to further predict on further images. You can change the model, of course. I can try model 3 and predict again. And shortly this part will be completed. Okay, great. And as you can see here, these two types are predicted with high confidence. So we're done with this one for now. let's go on to the next one. This part is a little complicated. Roboflow already trains the models for you, but some people would like to perform training locally using their own computers or their own processors, workstations, and so on. So as you can see here, this model, model number 3, has been trained. It's taken up until 320 epochs to reach around 96, 97% MAP50. And as you can see here, the loss is quite good. How about performing this training not on Roboflow, but on your own computer? You can follow these steps over here. So first of all, there is no escaping annotation on Roboflow. So let's go back to versions, and you'd have to here download a piece of Python code as well, so you can work with annotated dataset locally or on cloud computing or on the cloud. And you simply copy this part, and it will call the dataset that is already ready for you or you've already created previously with the same train tests validation split you've already assigned over here, or you've already actually assigned in model 3. So if we go back to over here, these portions of codes are straightforward. First of all, you install a few things, Ultralytics and Roboflow. Ultralytics will help you install YOLO models. Roboflow will help you obtain the models that you're, the datasets that you're going to be training on. So again, you'll have to connect over here. You'll have to run code. So as you can see here, it's installed both libraries. You'll have to connect your Google Drive, and then you can start training the models. You can change over here whether you want a YOLO 11 nano model or a different kind of model. And you can check where the dataset has been downloaded, change the batch size, change the epochs, change the image size of each image. Perform the training epochs as you can see here. And then you get a summary at the end after epochs training has been completed of the precision, recall, MAP50 of all and each class. And then you can decide to, once you're done with training, drop all the images that have been created post training back into your drive. So for example, you can download the confusion matrix back to your own drive, the training curves, any validation images showing the model's quality, also any tests you've performed. So here I had 3 test images, and there's a little assignment I have for you at the end. So I'm not going to run this because it takes time, but whoever wants to train their own models on a powerful GPU for much more epochs than 300, you can do it using this Jupyter notebook. Okay, on to the final part, which is this notebook, which is a combination of segment anything model 2 and also the YOLO model that we've already trained on Roboflow, and also large language models. So over here at the very beginning, you have to connect, manage your sessions, delete any previous session that's using the GPU, and then run the GPU with this notebook. So over here, you have to first of all check that the GPU is being read okay. So as you can see here, it's Tesla T4. Okay, that's good to go. Make sure you are locked on to your working directory, and then start installing a few things, especially the model itself, segment anything model 2. This usually takes time, and as you know, segment anything model 2 is a pre-trained model, and you can use it in many smart ways to segment either full images or parts of a bounding box, or prompt SAM2 to find specific objects where you assign key points beforehand onto the image. Okay, so it should be done now. As you can see here, everything is installed. We've imported the SAM2 model. There are a few descriptions over here that explain these code snippet parts, so you can go over it as well. We've here implemented the large model. And this notebook is actually copied from a notebook that Roboflow already created. So we're going to first start with the SAM2 automatic mask generator model, or we're going to implement mask generation itself. You can see here it works by sampling single point input prompts in a grid over the image, for each of which SAM can predict multiple tasks. If we take a look down here at the output of the SAM2 model on a source image, as you can see here, it seems the segmentation wasn't very successful. was able to segment only like the film background and a few uninteresting parts of the image with slight modifications, as you can see here, such as changing the points per side, points per patch, the stability score threshold and offset. You can get improved segmentation, so you'll have to play around with these parameters a little bit to be able to get better results. And it really depends on the purpose of your work. Are you trying to segment surgical work or full teeth, or checking for other problems inside of this image? Now we go on to another part. What happens if we use a YOLO model from Roboflow to find specific teeth and then segment within these predicted bounding boxes? So you'll first have to install another library, another let's say module or third-party library, and then you'll also have to use the Roboflow model to perform inference on the image beforehand, that's one image. And then for each bounding box, we're going to segment the tooth individually. So as you can see here, we were able to obtain for each tooth different images and further segment in each one individually. This could be interesting if you are looking for specific objects inside of or beside any tooth. And as you can see here, you can go back and also change the parameters of the SAM2 model. And as a last step for this segmented image, can we make use of an LLM to support us in defining what's inside of the image itself? We can make use of Google's generative AI large language model, specifically Gemini 1.5 Flash. And maybe we can ask it to have a look with us at such an image and make further analysis from what it sees from the image. So as you know, Gemini 1.5 Flash has visual reasoning capabilities, and along with the text prompt, such as here, can we direct the large language model to search for specific information inside of the image and provide like an output table or a comparison or a diagnosis or a prognosis. So for example here, I was able to ask it this question. And again, I want to say here that this is a know-how an expert system. I still propose that human experts are assessing such systems, working without these form of assistance for all forms of cases. And for now, these systems aren't well revised. They're more for fun experiments, and they're going to require much more effort to improve them in the future. So I was asking it here to describe what it sees in each segmented region, maybe give us like a further assessment on the health of each tooth, and it was able to give us like a table of everything it sees and a description and further let's say suggestions. And you can drop this inside of a text box, like open a text box here and copy paste it, and you'll get this beautifully formatted table. And that's it for this video. Good luck with your projects. I'm looking forward to seeing your outputs in the presentations next week. Thank you.